Okay, so today we're going to talk about domain and range, and we discussed this in class, but I thought that maybe this video can help for some of you that are still struggling. So with domain, what you want to notice in general is if you see a function that's a rational expression or a fraction like that one, or if you see a function that the whole thing is under a square root like that one, there should be a couple of red flags that you know can't happen. For this one, you can't have something over 0, right? That would make it undefined. And if something is undefined, then it can't be in the domain. Also, with square roots, you can't have a negative inside the square root. So when you're thinking about what is in my domain, you have to avoid x values that are going to make what's ever in the square root negative. So with that, let's take a look. Okay, so here's our first example. What is the domain? Find the domain. And we'll talk about range later. Notice that instead of y, I'm using f of x. I'm using function notation. That's just another way to say y. So we want to get used to seeing f of x instead of y. So from the beginning, I'm noticing that, okay, I have a fraction and I can't have 0 in the denominator. So whatever value is going to make my denominator 0 is not in my domain. Can't be an x value that I'm going to include in my answer. But other than that, I can have a fraction where this denominator can be negative, this denominator can be positive, this denominator can be any number at all, it just can't be 0. In fact, I can plug in 0 because if x is 0, I'll just end up with 1 over negative 7, and that's a number. But this whole thing can't be 0 because it's undefined. So what value of x is going to make this 0? 7, of course. So but my domain can be any other number except for 7. So how would I write that in interval notation? Well, we know it can be any negative number, so negative infinity up until 7, soft brackets, meaning that I can get very, very close to 7. I can have 6.99999. I can have 7.00001. I just can't have 7. So the domain is from negative infinity to very close to 7, union with, or along with, 7 to positive infinity. What that's saying is that I can include any number in my domain except 7. I have to skip over 7. 7's going to make that 0, and that's how I write it if I'm skipping over 7. Okay, let's take a look at another example. Okay, let's take a look at this example. From the beginning, I'm noticing that I have a square root, and I know that whatever's inside the square root cannot be negative. So I know that whatever value of x is going to make that whole thing negative cannot be part of my domain. So what's going to make that negative? When will 2x minus 3 be negative? Well, to figure that out, set it equal to 0, since 0 is the closest you can get to being negative. So if 2x minus 3 equals 0 and 2x equals positive 3, then x equals positive 3 halves. And check it out. If you plug in 3 halves back into this function, right, you're going to have the square root of 2 something minus 3. So let me change colors just to kind of emphasize this. Okay. So instead of x, I'm going to write 3 halves. And 2 times 3 halves, you can see this cancels out, and I'm left with the square root of 3 minus 3, which is 0. And the square root of 0 is 0. It's not undefined. The square root of 0 is simply 0. So at 3 halves, I get 0. Any number bigger than 3 halves, I'm going to get a negative number. Because what's 3 halves? 3 halves is 1.5, right? Any number, I'm sorry, smaller than 3 halves. Let's say 1. Let's say I plug in 1. If I plug in a 1 here, now I have the square root of 2 times 1 minus 3. Well, as you can see, that's 2 minus 3, that's negative 1. And the square root of negative 1 is an imaginary number, right? It's I, but that's a whole nother subject. We're just working with real numbers right now. So What is the domain of 2x minus 3? Well, the domain is going to be, it looks like I can use any number as long, the smallest number I can use is 3 halves, because any number smaller than 3 halves is going to give me a negative number. So how do I write that in interval notation? Well, you always start with the smallest number, and I can include 3 halves, so I'm going to say from 3 halves to positive infinity, because I can include 3 halves. 3 halves is only going to give me 0. Any bit bigger than 3 halves, I'm sorry, any bit smaller than 3 halves, I have a negative number in that square root. So the smallest number I can have without making that go negative is 3 halves. So 3 halves into infinity. And try, if I plug in, for instance, an 8, now I have 16 minus 3, positive number. I can plug in 100. 2 times 100 is 200 minus 3, positive number. So that's the domain. Okay, we're going to look at range now. For range, we're looking at all possible y values. So let's just look at the function we just finished looking at. But now my focus is going to be here on the y values. So we already talked about the domain. The smallest number the domain can be is 3 halves. So if the smallest x is 3 halves, what's the smallest possible y value? Well, remember when we plugged in 3 halves here, when we substituted 3 halves for x, we got 0. And 0 is the smallest y value because I'm never going to get a negative number. So 0 is going to be the smallest y value. Let's take a look at what other y values I could get. Well, if I plug in 1 for x, let me just finish this. Okay, so if I plug in 1 for x, notice I'm going to have 2 minus 3. That's negative 1. That's undefined. So again, I'm never going to get a negative y value. But if x is 4, I'm going to get 8 minus 3 square root of 5. If x is 100, I'm going to get 200 minus 3 and the square root of that, so the square root of 197. So I'm going to get all kinds of numbers, but the smallest number I'm going to get is 0 because this will never go negative. Therefore, the range for f of x equals the square root of 2x minus 3 is going to be from 0, including 0, all the way to positive infinity. I can get any kind of value for y as long as it's positive. Let's take a look at another function. We'll do one more. Let's say my function was f of x equals x squared. Let's look at the domain and the range for this one actually. So the domain, all possible x values. And here I don't see a fraction, I don't see a square root. So it looks like I can plug in anything I want and it's not going to be undefined. So my domain is going to be negative infinity to positive infinity. And remember, we always use soft brackets when we're dealing with infinity. How about the range? Am I going to get any number in the number line? If I take 5, I'll get 25. So again, sometimes it's helpful if you draw the xy chart here. So if I plug in 0, I get 0. And remember, for range, we're going to be looking at all possible y values. So, okay, let's say I plug in negative 10. If I substitute negative 10 into the function, now I'm going to have positive 100. If I substitute 7 for x, I'll get 49. If I substitute negative 8 for x, I'll get positive 64. Looks like whatever negative or positive number I plug in, y is only going to give me a positive value. And take a look, when you square a negative number, you'll always get a positive number. In other words, y will never be negative. So my range will never have any negative values. So my range is, again, the lowest possible value I can have is 0 up into positive infinity because my range will never have negative values. And that's it.